So you got one of these bad boys, huh? Some kind of Clark Forklift or something with a Continental L-head engine? Well, I've got a few tips for you, and this video is going to show you how I changed out the valves in this and the valve guides and springs, and I ground the seats and the valves themselves, changed the coolant, and just kind of did an overhaul on this engine. Oh, I did also hone the cylinders, although that's not shown in this video. But here's a few quick steps tips for you to get started, actually. So here's a few quick tips for you to get started with this. There is a manual for this online, and so if you look up L-head F163 overhaul manual, or if you just look up L-head overhaul manual, there's a PDF with a lot of good information in there. You should get it. If you're just starting out with this kind of thing, make sure, if you're going to try to start it beforehand, or if you're troubleshooting, make sure it has fuel. You know, if it's propane or if it's gas. You can also check to make sure the high pressure fuel is getting there if it's propane. But obviously, you know, you're going to make sure it has fuel. You're going to check for a spark. One thing that I used to diagnose this is I checked for compression, and the compression on this was terrible. It was about 30-something PSI in one cylinder, maybe 50-something in another. So I knew immediately something was wrong. I think 2 cylinders had very, very low compression. So that led me to believe there was a blown head gasket in this, which I think might be common on some of these older forklifts or some of these older engines. Another thing when you're trying to start these, mine in particular at least, has a forward and reverse and neutral lever. It's right over here alongside the steering column. That has an electric switch in there. If that's not in the right position, if that switch isn't activated, it won't start. It won't want to turn over even. So for a while I was jimmy rigging it, and I would turn the key, but I would circumvent that switch. I would actually just activate the starter solenoid directly, but the forklift wouldn't start. So that was one reason. Anyway, long story short, yeah, you are going to want to check for spark. If you don't want to remove the head on this, it's possible that your valve clearance is bad, and that's why you have low compression. The valves aren't fully seating. You can take off the side cover on this really easily. Just look at the overhaul manual. So without taking the head off, you can remove the exhaust manifold. Then you take this little panel off. Really easy. You can use silicone to create your own gasket afterwards to reinstall it. So you can easily adjust the valve clearance with just, I think it's like a 1/2-inch wrench and a 5/8 inch wrench, or 9/16, something like that. Super easy to do. You'll need a feeler gauge. It's like 12 or 15 thousandths. What else? If you want to check the timing on your engine without removing the head, you can do that by looking at this video, because I show you where in the cycle the valves are going to be. Because if you pull the plugs on this engine, you won't see the pistons, and you won't have easy access to see the pistons or where they're at in the cycle. But in this video, I do show you where the intake and exhaust valves are relative to where top dead center is for your number 1 piston. And your number 1 piston, by the way, is this first one closest to your fan pulley. And by the way, you can turn the engine by putting, I'm going to switch camera views here, turn the engine by putting a chain wrench on this pulley. So mind you though, this pulley is not going to be very accurate in like if you mark it for timing, it's going to be kind of pointless, because the belt can slip on that, because this is driven by the main by the crankshaft down at the bottom. But that being said, you can turn the engine if your spark plugs are removed by turning this with a wrench, and you can look at your timing and see if that's right. And on that accord, at least on this engine, this one here, I believe is the Y-112 engine, but the distributor needle in there, it turns counterclockwise, not clockwise, counterclockwise. And on my engine, the firing order is listed. It's 1342. So check the top of your engine for the firing order. I think probably most of the Continental engines were 1342 if it's a 4-cylinder. Not sure about the 6s. What else? Oh, to change the valve stems or springs, but the stems on mine had a lot of play. And since I was going to remove the valves to lap or grind the seats and the valves also, I did change the stems, and you will need specialized tools. You can look through this video to try to build something if you have a welder and a grinder or something like that. Or if I find these available online or decide to try to manufacture these, I'll try to post the link at some point. But you pretty much need specialized tools that can exert a lot of force. And even with these tools, you're going to end up needing a sledgehammer. Just go forward in the video to take a look. And then the last, two more last tips. Before you start disassembling stuff, if you're going to, these are older. Most of the bolts and nuts are raw steel. So do yourself a favor, get some WD-40 or something similar. Spray down everything you're going to need to remove, like all the bolts and nuts and all that stuff, just to make it a lot easier. It will come out more smoothly. Some of these nuts and bolts are in kind of hard to reach places, even with wrenches, so you're going to be trying to turn it with your finger a lot, most likely. So WD-40 it. Okay, just checking out what I did here. Took these bolts off that hold this bracket on, put them back in the holes. Took the nuts off of here, took a clamp off of this. There's the clamp and hardware. There's the bolts, or the nuts and washers that were on here. And this thing just broke off. It goes to this here. We just want to kind of take in everything and see how it goes together. This hose is going over here to that. This big guy, that's no big deal. This one here from the middle of this unit is this here. It's this braided line which goes up here over there. So I'm going to be taking that off of there. So white cotton one goes to that. That's about it. Okay, just real quick, this linkage system here. This pin is in the hole closest to this. There's two holes in that little thing, so it's in that one. So if I get it out, we need to know where that goes. So this is wide open now. Just gotta take a look around, see how everything is hooked up. Some of this might be annoying to put back together. Gotta look and see how that carburetor comes off. This is kind of an intake manifold. It looks like the same bolts that hold on the exhaust might hold on the intake manifold. So I'm thinking if I take those nuts or bolts off, the manifold will want to come out, sort of. But I might have to take these out, and then that might come off, and then the carburetor can come off. Okay, real quick, I did get the header off. It wasn't hard at all. There's a linkage that comes off of this, and then obviously those bolts hold those on there. Just real quick, so this is that linkage that was connected to the carburetor. This guy I did finally get out, but I had to disconnect the pin from the other side of this rod so it could actually swing out more. This pin was originally in the other way, so the butt end was pointing this way and running into this, so I think it's important to swap that around. Real quick note, I couldn't get this panel off quite yet because this line, some kind of hydraulic line of some sort or pressure line, is mounted to the bottom here, so this panel would want to run into this. Not only that, but this pipe wants to run into that. Well, especially the pipe. And this pipe I wasn't able to unscrew from the bottom. Word to the wise, be cautious about trying to unscrew this. I think you can just leave it on this panel, because this panel is a little bit weak, and I thought I heard some flexing or a crack when I tried to turn this with a little too much pressure. When I turned at the bottom, I wasn't able to stay totally concentric. So, it wiggled to the side and flexed it a little, which is no good. What I'm going to do here is I put these nuts back on. I'm going to cut these bolts shorter because these bolts are a lot longer than they need to be. These two bolts that hold that on. And so I put the nuts back on. I'll cut that off, take the bolts off, clean up the thread just a tiny bit, maybe with a die. And then that panel should be able to come off. Oops, hold on, let's zoom back out. It'll be able to make it over that and come up. So then I should have access. These two things are probably going to have to come off. I believe they're held on just by this large bolt there. But overall, this, you know, I spent maybe like an hour doing this. Probably spent another half hour taking off the head. So you can get at those valves, I think, in probably roughly hour and a half, 2.5 hours, something like that. I wasn't able to turn over the engine by hand. By the way, the front of the engine is this side with the belts. I mean, I don't say that as a fact, but just from other videos on YouTube, they always say the side with the belts is the front, and then the side that does the work is the back. So that makes this cylinder number 1. So originally I did have the firing order wrong, which is kind of a super obvious and dumb mistake to make, but just so you know for the future. There's a big socket down at the bottom on the crank. I believe it would be on the crankshaft on the bottom here, on the front. Not a big socket, but a big hex. So you could potentially put something on there, but I think it's probably pretty difficult. I think it's probably a lot easier just to use the starter to turn the engine over. Okay, got the cover off. Pretty nasty in there, as you can see. I think what I'll do is I'm gonna take this pipe out and just put a rubber hose on there. I mean, the truth is you could probably leave it. That pipe's only bringing it down another foot, but it's definitely in the way with this oil line. This does swivel, but I'm not sure. I did turn it slightly, quarter turn counterclockwise to loosen it. But then you'd have to bend this, and also you're gonna break that seal, and you're gonna have to tighten it back up again, potentially slightly more than where it was before. So I'm gonna have to do that now. But ultimately what I did is I took this little thing off, which wasn't hard, just that bolt holding it on there. This I just bent outward a little bit. It's some kind of, it's an oil line to your oil filter over here. So I just bent that a little bit. Obviously you want to be kind of gentle, but I think, you know, it can handle a little bit of bending as long as you don't kink it, you know, and damage the metal to leak it, cause a leak. Anyway, pretty nasty in here. So I'm gonna have to plug those holes, clean all that out before or after removing those valve springs. And those springs are difficult to compress. They're basically just like normal car springs on any 4 or 6 cylinder car, you know, and there's not a lot of room for compression actually. So I'm still thinking about how to take those out. And I'm not even sure what's keeping the end caps on the valve. I'll need to look online if it's normal keepers or how those are held on. And something to think about too is if those should be taken out with the head on or the head off. Potentially the head could help retain those valves if you make a mistake. I don't know if it could bounce one out or not, but that's about it. Okay, what I did just now, which is why it's so wet, and it's pretty much water that I had in there at this point, but I disconnected the hose clamp at the bottom of this radiator hose coming from the water pump, drain the fluid so that when I take the head off, the fluid is, I mean, that point's lower, so I think none of that fluid will be leaking out when I take that head off. So my next step in this is I'm going to remove this bottom mount hose here. I might just take the hose off because I just want to leave the rest of that on there if possible. This bracket's going to come off. We're going to swing it around to the other side. And this is just so I remember too here. So I believe, yeah, there's a bolt right there, kind of under my finger, holding that on. And then there's probably one somewhere over here. Looks like there was one, but it's missing. So anyway, maybe there's just one bolt to take off, and then that bracket will come off, that'll come off, and then probably just take this wire off and leave this little unit on here, this cooling unit, and then take those head bolts out. Then the head will come off, then we can access those valves and potentially use the top surface to help get the springs off if necessary. Okay, I already began taking these head bolts out, and you may have noticed that yours may look a little different. I think these are 9 like high strength bolts, number 9 or something like that. And I just wanted to be sure that I wouldn't break these when I tensioned them down. And so, okay, I just felt it go down to the bottom here. When you're doing this, make sure you don't drive it onto your tappet, or at least not too hard. That's something that I just worried about just now. Also, you don't see it, but it would be wise to put a paper towel over these holes so nothing goes down in their oil pan. But yeah, so anyway, I just got this out. This is what the end of this tap looks like. I would use a smooth wall thing. This is not a good idea using rebar. I did turn it down on my lathe. You can see the little centering device. And I'm a little worried about, oh my God. Yeah, see? You can't exactly just take it out of the bottom. So I'm gonna have to figure out how to get that out yet, because it's still kind of in the top. And now it's sitting on top of that tappet. I thought basically there's an empty cavity around it, but it's not enough to just take it out of there. So I might have to remove the valve spring over here and then cut it. Obviously not the best solution. So just be aware of that. You can't just take this out of the bottom. You might have to unscrew this bolt first. So I'll try that on one of the other ones and just see how long the tappet is and see how much space is there. But you can't just leave the tappet with that nut on there, or the bolt adjuster, and take the guide out. These are newer because I replaced the head gasket in the past, thinking that that might have done the trick in fixing this motor. But it wasn't. You know, the valves have some major issues, and hopefully not the piston rings. But long story short, I don't know if your engine's gonna be the same, but this engine has, I think it's 2 bolts, these 2, that are larger than these other ones. So you got to mark them. Mark your head too. And don't get confused when you're putting this back together. I think I got confused, and I put a small bolt in one of the larger holes. And it could be that one of these holes, at least one, may now be bigger, even though originally it wasn't, because I stripped the threads and had to retap it or something. I really honestly can't remember at this point, but I do believe at least one of those bolts was bigger when I first did this, hence the resulting confusion. Oh yeah, this one here looks a little bigger too. So I'll try to put the bolts in the description. I bought these on McMaster-Carr. I don't make any money off of that, by the way. Those bolts worked out really well for me. A little bit pricey, but in my opinion worth the risk. Worth avoiding the risk of breaking an older bolt. And so I did break 1 or 2 old bolts when I took this off the first time. I had to heat 1 or 2 of them up. They're pretty rusted in there. I think this thing sat a while, leaking coolant in the head, so it was just pretty bad. So I had to use a vice grips and alternate heating with an acetylene torch. Propane torch will probably work fine too. Anyway, to get that stub out, which I did, so it did work out. But here I am working on this engine again. Okay, the head came off easily enough. You're seeing some weird colors in here because I had put some dish detergent in here earlier on to help clean the radiator system. And honestly, I put some baking soda in there too, because prior to all that I had run some CLR in there. I wanted to neutralize any acids. Long story short, if I did that all over again, I would make sure I thoroughly flush the system immediately after. Anyway, point is unhooking that radiator hose doesn't drain the coolant in here. So look at the manual. There's some kind of drain plug on the block somewhere where you can drain the fluid out of the block. So make sure you do that beforehand, otherwise you're going to have water in here. This piston was full of water. Good news is it wasn't leaking down, so I think the rings are good. But other than that, the head comes off easily. Just remember again that some of these bolt holes, pay very close attention to the bolts you remove and their location. On mine, 2 of them are larger, so there's that. One thing when you're doing this, I already took the keepers off of this valve. You can see this is an intake. More than likely your intakes are going to be fine. If you're not so sure that you need to do all your valves or stem seals, I just noticed there is a little bit of play in this stem seal here, or the guide, the valve guide. Anyway, if you're not sure if you're going to do it, don't take it off. Just look at the ones in most need first. Another thing is these adjusters down here. If you put a wrench on the bottom one and turn the nut, you can see it right here. You can see how there's kind of a bottom piece and a top nut. If you hold the bottom one stationary, adjust the top one, you're adjusting how much the valve goes up or down as it's actuated by the cam. So if you know you're going to adjust it anyway afterwards, you can go ahead and run that nut all the way down to give more play in the spring. I'm not sure if that, yeah, that should get you something, because what you're doing is you're lowering the height of this, and this is going to be in the way when you take those keepers off. I already did take 2 off. I think getting them back on is going to be a pain. What I did is I just put a socket right there, like this, and then I used a wrench of a big enough size, and I put it on the socket as a fulcrum, and I pried up on the bottom of that, the springs, the seat that it rests on. But honestly, I think getting those keepers back on by that method will be too much trouble, so I highly recommend using some kind of spring compressor. I think there are tools that will come in underneath that seat or kind of alongside of it and cup under it just a little bit, and then it uses this top surface and you're just pinching it together, you know. So then that would make reassembly a breeze. Trying to hold this with one hand and having stuff in the way and putting those keepers on with a strong spring like that is asking too much. So I think you should get yourself a spring compressor or make a jig. The only way that I was able to get this valve guide out was by using this C-clamp device with some strong forks on one end, and I would tighten this thing up so tight that the rod began to bend up here. So I used this, tighten this, then I used a 3-pound hammer and gave it repeated blows on top. I felt like the jostling and the tension can really help. Prior to this, I did try an air hammer. I did try pounding directly on the rod. Make sure your rod is a little smaller OD than the valve guide itself. Also, I'll show this after a minute, but it helps if you have a centering device on your punch or whatever sort of rod you're using to drive the guide out, to keep it right in the center of that guide so you don't scrape the walls. If you do, it's probably not a big deal as long as the overall size isn't hurt too much so that you can press in a new one. But yeah, that's the only way I was able to get it out. I also did try pulling it out from the bottom by using a bolt, a socket on top. That also didn't work. So honestly, I would estimate this at least 800 pounds of force pushing that rod out. Probably well over if you consider the impacts from I believe there's a 4-pound little sledge here. A smaller hammer might work, but I do think the weight really helps. Don't damage your clamp by hitting it too much. Always keep like a lot of tension on this so that this can soak it up. So your impact will make it loose, and then all the tension in this, because this is bending a little bit, is going to help carry your swing through into that valve guide and drive it out. If you want to replace all of them, that's cool. If you only replace the ones that need it, I think that's cool too. For whatever reason, the intake valves on mine were significantly looser than the exhaust valves, which was a surprise to me. I'm not sure if you can see that. There's not as much side to side. Let's zoom in a little bit and I'll try to study this. Well, that's a lot of play. There's probably like 30 or 40 thousandths of play almost in this valve. So obviously you can take the bolts out of those tappets, But this is how long they are. I don't know if it's about 10, 13 threads. So ideally you'll have a ratcheting style wrench. And by the way, it's a 1/2 inch on the top and 9/16 I think on the bottom, yeah. So the 9/16 goes down there, and then this guy here is a 1/2 inch. So if you have a ratcheting 1/2 inch, the job won't be too bad. But the reality is, cutting through one of those valve guides was about as annoying, and it took about as much time, maybe even less time, than undoing this whole bolt out of that tappet. By the way, with this valve guide out, the tappet can be removed, and I'm hoping that with the nut out, or with the bolt out of that one, I can remove the guide without taking without cutting it. Let's see, so you can remove these, but only with the valve guide out of the way. This had, here we can look at it, this had very little wear on it. I mean, it's got like maybe either some stress marks from the cam, or maybe that was made that way. I kind of think it's stress, but honestly I didn't see any wear on this, which is pretty amazing and pretty neat, especially considering this engine is probably designed to use leaded fuel, and so probably it could benefit from a zinc additive in oil, which I'll probably do. After some research, people tend to use a different valve seat for engines that are running without lead in the fuel. So these engines probably have valve seats that are a little softer due to using leaded fuel, which dampens the blows, apparently, from what I hear. Just real quick, I made this spring compressor, but honestly you could probably just buy the $50 one from Lissel or Lissel Tools, whatever it's called, and probably be better off. Honestly, it takes a while to do something like this, and look at it. I call it the dinosaur from hell. No, but it does work well. Let's see if I can, I think it's a good idea if you're compressing a spring to help it at first if you do make something like this. Let's see here, is this gonna burn me? All right, there we go. So something like that, adjustable, pretty nice actually. And then this is a Harbor Freight vice grips. It's the type where you pull on this release to let it go, which I'm going to do right now with my foot over this. So that's a lot nicer than the kind where you push the other way. And then just real quick, this is what I did for the clamp device for getting out the valve guide. This worked really well. Had to cut part of the clamp off. Again, a Harbor Freight tool with quick release on the clamp, quick adjuster. This, I do have a lathe, so I turned down this cylinder a little bit so that it can nicely accept the end of a punch to kind of help align it, because you don't want this thing wiggling off. I did keep this pivot, but I don't know if that's really necessary. For whatever reason, I did grease that, but even with this not greased, it wanted to turn inside this, in between this piece and this piece. So I went ahead and I put a little grease in between, and then to make sure this stays extra straight, a guy could weld that. But again, if you can buy, or better yet, rent such a tool, probably be better off. Honestly, probably spent about half a day making these things. Probably worth like $100, but then again, it depends on what your time's worth. So both of these will do the job. I think you pretty much need a tool like this to get these springs back in and get the valve seats back on. Also, if you go ahead and make something like this, make the front edge beveled a little bit, you know, with a chamfer on it. See that? So you can stick this on over an existing spring easily, and it'll, you know, chomp right in there, and then you can compress it and take that spring out nice and easy. I was able to turn this belt pulley, the fan connector, whatever it's called, on the water pump with a chain wrench here. See that? So I'm just turning it clockwise if you're back here looking that way, but I think you can probably safely turn it both ways. But this is also a way you should find top dead center for your number one piston. You'll probably remember that the spark plug is kind of over the valves for whatever reason. So it's hard to know where your top dead center is unless you take all the spark plugs out and you pay attention to the valves too and figure it out that way. Just easier to note it when the piston's at top dead center for the number one. Note it on your pulley somewhere somehow relative to something else. And there you go. I got all the springs out. One thing I'm going to do yet here is make a spacer that I'll set in here so that when I push the new valve guides down, they can hit that spacer and I won't have to worry too much about trying to measure, especially because the plan is to cool the new valve guides with dry ice to help them go in a little more easily, hopefully avoiding damage as they go in. What I've done here, you can see, is it looks like there's a valve guide there, but that's actually just the little top of one. I turned it down on my lathe. I know not everyone will have one, but I did take off about 1 thou. So there's really no side-to-side wiggle, or it's almost negligible. And so I've been using that when I've been grinding this seat a little bit. And I should have showed a before shot here. You can see a little bit of the evidence of it. But basically on this edge, there's some pitting. There was additional pitting along the top here, top of my finger. And I didn't want to use a typical valve seat cutter because I was worried that with the limited number of cutting portions on that, it'll cut more in the areas where there's less resistance, basically. And then same thing with the if you wanted to use valve lapping compound or some grit, I was scared that some of the grit will rest in the pits. So then as you turn a valve on there, unless it's a junk valve, you're going to wear the valve away a lot more and you're not going to dig into the rest of this quite as much. And in fact, the grit in any pit will help resist any cutting in the area of the pit. So basically what I did here is I made what I would call a poor man's grinding wheel. I used one of my existing valves. If I did all this over again, I would buy an extra single valve so I could just scrap one of my old valves if I wanted. But anyways, I used this. I hot glued a little thing on here. You can see that, so that you can use one of these flexible shafts on a drill so that it won't tear this piece off the valve by being off center just a little bit. So it allows it to move really easily. And then what I have been doing is I've been using 220 grit sandpaper, and I'll put just a little bit of hot glue on that, and then I'll put the strip on. I'll put one strip on each side. So basically the idea is that this gives a very rigid structure to the whole thing so that the pressure is equal and it's wide enough so that the abrasive doesn't dip down into any pits. So I have been grinding that a little bit. I think I'm just about done. And I did hit this one too, just very lightly. And I'll probably just hit all of them really lightly, you know, and basically remove all the pits and then go straight to lapping with maybe around 400 grit or 600 grit. That's what I did, and I think it'll work out. I did go ahead and make a mark on my water pump, I guess, and then also on this pulley. It's moved now since I've since moved it, but I went ahead and marked top dead center for that first cylinder. Anything else in this video? Getting those out was pretty difficult. Here's the top of that wrench, or the clamp, after pounding on it. So that's with this large 6-inch clamp pretty much maxed out. You know, this piece here can't retract because it's so bent up. You know, I probably used that to apply a good 1,500 pounds of force, and then on top of that I was beating on that with a 3-pound or 4-pound sledge, whatever this is. 4 pounds. So I had to hit that pretty good to get those out. So I am concerned about getting the new ones in without damaging them. Something to consider, you know, what you're putting them in with and how you're putting it in. My plan is to just use this to press the new ones in. Probably at first I'll use the sledge to give it a very gentle tap to kind of seat it in. The reality is, if it goes in easily enough being cold, I'm just going to tap them in. But if it's not very easy, then I'm going to quickly put this clamp on there and try to press it in, whatever the remainder will be. I did have to turn down my guides. These are the originals. The ones I bought a little bit on the long side. I knew the diameter dimension was the same. I did shorten them. I don't think you need to beat yourself up over the length. You just don't want it sticking up too much, because it'll block the flow of the different gases coming in and out of the engine. And then obviously it can't be sticking down too much, or else this, along with the valve seat, or sorry, the seat for the spring, will run into that. You definitely don't want that to happen. So just as long as you're within those constraints, I think there's actually a little bit of flexibility there. Okay, I just got all the new valve guides in, and to do that I did just go ahead and use the 4-pound hammer and this, and I tapped them in. Didn't take a lot of force, but it did take a little more than what I expected. I did go ahead and soak these in alcohol mixed with dry ice. Should be very careful, that mixture is kind of dangerous. If you get it on your hands or in your eyes, it can freeze you instantly, of course, so be safe. One point of note, if you look closely, you can see damage to the surface of that. It is just face damage as far as I can tell, and I did insert a valve and it moves smoothly, like it inserts fine and nice and tight, has no discernible movement really, so that's nice. Hopefully that'll be the same with all of them. That was the only one that did incur some face damage. You have to move quickly. I do recommend using some kind of stop, but it's not the end of the world if this is sticking up a little higher than it needs to be. All that's going to really happen is it's going to impair the movement of the gases, whether your fuel or exhaust. And then down here, it'll provide just slightly less, longitudinal, latitudinal support for when this pushes up against it. But in my opinion, the whole movement's so vertical that it shouldn't really matter. So basically, I guess I'm saying err on the side of don't put it in too deep. If it's in too deep, you're going to have to push it all the way through and start over, or you're going to have to cut some of the bottom off, which is probably the route I would take, to be completely honest, because you're going to risk damaging it otherwise. So now the next step would be to do some valve lapping. I made my own compound. I did go ahead and use a water-based version at first, but I was pretty unhappy with it, and the reason why is that stuff can move out away from where you're lapping, and it dries up. So, and as you're lapping, it can dry up and create little balls. I made an oil-based version, and I was much happier with that, like oil mixed with grease and clay on the grit, something like that. Or you can just buy something. But anyway, the reason being is that stuff won't dry out, and so it won't clump up and fall away into other areas. But you're going to have to think for yourself how you want to do your cleanup, because obviously you need to get that stuff pretty much completely removed out of your engine, or it'll wreak havoc afterwards. So think strongly about how you want to perform your cleanup and what kind of solvents you're going to use, whether water-based setup, or if you're going to let your whole block stay kind of oil-based and clean it with oil and maybe a little bit of gas or paint thinner or something like that. I don't know. You're going to have to think about that for yourself. Remember again, just to use, if you're doing really coarse lapping, in my opinion, it's okay to interchange valves, but just don't lose track of them. When you do your final lapping, make sure you're using the valve that was originally in the position, or that's going to be permanently in that position to do the lapping, so that it can find a close mate to it. When I was doing this lapping, it does become evident how much contact there is between the valve and the seat, especially if you're turning it and then you quickly move it up. It doesn't have any time to come back and collect over the surface, so you can tell how much of a seal is being created. There's really no need to use any kind of compound afterwards. I know some people use machinists like marking inks and that sort of thing, but I think you can tell. Also, you know, it's been said there's no substitute for a good valve grinding job. Like lapping is no substitute for a good valve grinding job. I mean, I tend to agree, but it can be hard for backyard mechanic to do a good valve grinding or, you know, machine cutting of the surface of your valve seat. That being said, I think the method of using sandpaper attached to the underside of a valve can do a pretty decent job at fairly quick removal. Although, as you can see, I did have to go through a lot of different pieces of sandpaper to do that. It probably took me about 20 minutes of grinding or working on this to get to a point where there's no rust pitting. I do believe the rust pitting was probably around 15 thousandths deep into the existing seat in my case. So I think, you know, I'm at the very low end, probably not meeting spec for how deep into a seat you can cut. But I honestly think it'll be totally workable. Also, the bottom of the valve stem still isn't contacting this, so there'll still be room to leave clearance between there as required and as necessary for proper seating of the valve during operation, you know, because that valve needs to be able to seat completely to seal that off. So you're going to need to be aware of that. If you go down too deep, basically the only caveat, in my opinion, is your clearance at the bottom, which potentially can be mitigated by grinding away a little bit of the bottom of your valve stem if you really need to, and potentially the bottom of the keepers. Mind you, you're going to be limited in that to how much you can take away. But then the other thing that's going to happen is your valves in the topmost position simply won't be quite as high up. So your flow of gases might be slightly impaired, you know, because the farther down you go subsurface, the less area is open when the valve is open. So, okay, this is with the after the lapping and some cleaning. So probably not completely perfect, but I think sufficient for a long life on these yet. I think maybe in a few thousand hours from now, maybe 4,000 hours or something, someone will probably want to revisit this if it's worth it. Pop these seats out, put in new ones. So now it does have you know, all the lapping done and the guides in, and I cleaned everything multiple times using solvents and then also a tack rag. You want to be especially diligent about it if you have rough surfaces with pitting like that can hide debris. You probably don't have to worry quite as much about the exhaust, the various exhaust ports, just because that's going to be on its way out. But you will want to clean inside here very well with solvents, and probably you know, blow it out with air a few times and then use a towel. About lapping, I found it to be sufficient to use kind of a rougher grit mix of around 240 grit, because as you're grinding, it's going to get broken into smaller pieces. You don't want to grind too much. You just want to, you know, do it enough to create a good seal. I think, if I remember right, the spec is something like around a 1/16 of an inch or greater is pretty good. You'll see we have about that on most of these. Let's see here. One thing when you're doing the lapping, I mean, I'm no professional, but what I think works well is to lift your, whatever you're doing the lapping with, you know, probably you know, one of your valves, but to lift it up from time to time, and then as you go down, put progressively stronger force, and you'll feel a difference. So at some point, if you're pushing too hard, you're going to squeeze out all the grit from the areas that are making contact. So the reality is you'll have minimal grinding in a very high pressure zone and more grinding in kind of this in-between zone where the larger pieces of grit can exist. And that's what you don't want, actually. So don't use too much pressure, and then make sure you lift it up and then kind of bounce it up and down a few times so that the grinding compound can be pushed between the two surfaces again. Because otherwise, if you just keep pressure and you just keep it on, you know, you're going to squeeze out your paste and your grit. The larger grit especially is going to work its way outward due to the pressure, so just be cognizant of that. Okay, in my opinion, the best way to put this thing back together is to compress the spring and the valve stem, or the spring base, I don't know what you call that. Compress that together like this, with the spring sticking out a little, so you can get that spring over the, I'm going to set this down, but you know, over the valve guide. And then there'll be enough space, you know, this can all go in there. You're going to then release it. Then you're going to use this tool and compress that whole assembly to expose, you know, the little area on the bottom of the guide, the valve stem, to expose this little notch, you know, to get those little retainers on there. So in installing these, you can press right against the valve on top. In fact, it's probably for the better because it secures it. And so then the bottom, of course, is pulling up on the spring seat or whatever that thing's called. And we can see the valve stem sticking out of the bottom. And that's what you're going to put that little stem keeper, or whatever the little half ring dealy is called. These guys. Just real quick, a couple points of interest. This is one of the spring seats or boots or whatever you call it. It goes on the bottom. In my engine there were two styles. You'll notice this is a single piece of steel. The other style had a little spinning disc, and I didn't pay attention which one goes where. I don't think it's a huge deal if you don't put it in the right spot, but it was probably made this way for a reason, is my guess, unless someone was in here, because I did have 4 of each style. I do believe that this style without any spinning disc went on the exhaust valves, and the other style went on the intake for whatever reason. Another point of interest is I bought some of these retainers. You can see one there. That's an old one. It's dirty. This is a new one. I have no doubt that both will work, and the taper is probably the same. I did put this on the stem and it seats fine, but just keep it in mind, because you probably want to use 2 of the same on the stem. Don't mix and match, just in case it does something weird. And then what else? Buy yourself some springs. You could buy some extra of these and some extra keepers. All these new springs were about a 1/4 inch longer or so than the old springs, so I replaced all the springs. This one has yet to go in, but all the springs are new. I'd also personally recommend potentially buying one of each type of valve as a just in case, because they're only $10 each. 2 of the springs that I took out, here's some of the old ones. 2 of them came out broken for whatever reason. One of them may have broken while I was taking it out. The other one I think was already broken. Seems that the brake had a little bit of rust on it, so I believe it was already broken. But that's why you may want to replace just all your springs and be done with that. After you've put everything together as far as the valves go, after those are all in there, turn that thing over a few times. Use your gauge, you know, check your dimension as to what the spacing should be between the tappet and the end of the valve stem. And I'd say turn it over a couple times just in case something's not really seated all the way, or in case the keeper isn't holding and you thought it was, or something like that. And so turn it over a few times and pay attention to, you know, obviously this is the front of your engine, number 1. Pay attention to the cycle that it's in. Right now I just found top dead center, so it's ready to blow off, you know, so I know that how to do the distributor timing. And then don't mark this, because this pulley, it must be like half the size of the crankshaft pulley down there, and the belts can slip anyways. I marked it up there, but it's just not a good idea. What I then did is, and maybe you'll have a better idea, but marked it underneath here, right on the pulley and then on a bolt. It's not 100% accurate, but hopefully it should be good enough to get close. And then I read some stuff online. Some guy made a post about how to find timing, and as long as you're pretty close to top dead center, you get your distributor cap lined up, you know, so that the firing order is the way your engine says it is, you know, all the connections are made right. And then you'll note that the thing in the distributor, the connection, right when it touches to discharge to cylinder 1, you know, cylinder 1 should be at top dead center. So that should be your starting point. Crank it over. If it doesn't start, move it around a little bit, the distributor, as you're cranking it. You know, just a couple degrees both ways. Find the spot where it fires. Then, you know, while it's idling, you can just fine tune it. It could be that you'll want to wait until it warms up after a little bit. But then you'll find the best running point, and hopefully that'll be where your timing is optimized. Another thing when you're doing this, you probably drained fluid from your radiator, so you know, don't forget to put fluid in there. Also, before you start it up, if you did anything weird, or if you think you might have dropped anything in the oil, basically if you think anything foreign other than oil got in here, you'll want to drain at least some of the oil down there to get whatever fell out at the bottom. Or if it's due for an oil change, you could go ahead and just change that oil. But anyway, at any rate, just make sure, you know, everything's free of debris. You got oil in the machine, you got all your coolant in there too, and should be good to go. One more thing too, for people trying to find their timing with their head on, I realize that the spark plug is somewhere over these valves. You really can't see the pistons, so it's hard to know where you're at. So top dead center is with the valves in these positions. You know, this being your pulley and fan, front of the engine, this being cylinder number 1. So both these valves are closed, and they'll remain closed through as that piston is going down. Your number 2, intake is open, exhaust is closed. 3, exhaust is open, intake closed. 4, both are closed at the moment. We're going to go ahead and come off top dead center in our normal cycle. So this number 1 is going to remain closed for a little while here. And what's key is, as it remains closed, your intake is still coming up on your number 2. The exhaust is remaining closed on the number 2. And on your number 4, the exhaust is coming up, okay? So that's where top dead center is, at least on this 4-cylinder L head. Oops. Before you put this cover on, you may have gotten the kit, comes with a rubber gasket. Personally, I wouldn't trust that hard rubber gasket with just 2 little bolts, you know, right in the middle of this cover to hold it on there, or 2 nuts rather. So what I did, and also another thing by the way, if you have the means, like a TIG welder, you can burn out a section of this to make it easier to put on and take off in the future. This looks mildly rusted because I had it in a acid dunk tank to remove any rust, and there was some. So what my plan is I'll just use a gasket maker and go ahead and put some oil on, a thin film oil on one surface, and then on the other surface probably no oil, because the idea is it might be nice to have adhesion on one side, and then in the future if it ever needs to come off, it can come off easily. So I'm just using this high temp silicone gasket. If you do use new head bolts or even old ones, either way, you'll notice that I don't have any sort of washers underneath these, and that I think is my only, hopefully that's my only mistake that I've done in this. And I mean, I don't think you 100% have to have washers, but if you look close on 2 of these bolts, the iron did chip when I made it to the head torque spec. Forgive me if I mentioned this earlier, but this linkage, when you're reassembling the engine, you're going to want to make sure that you install it right after you install the carburetor and the manifold, and before you put this whole thing back in. It'll just be easier. Also, even before you do this and before you do the carburetor and manifold, you don't forget to replace these 2 sensors or whatever they are. Make sure they're back on. It's just a 9/16 bolt right here. Other than that, I had to take some of this stuff off again just to get at this linkage. This is what it looks like close up. Don't forget too that when you do the manifold, there's this little bracket right here. You can kind of see it. It just goes on this second bolt from the front side of the engine. So there's that bracket. You can kind of see it. And that just allows the spring to hold onto it, and then that spring is attached to some kind of governor mechanism, I think. So don't forget about that. And then when you're doing all this, a little WD-40 or oil can really help on some of these pins. Either the actual like cotter key or whatever that is, and then the actual you know, the thicker pin that allows the force to be transferred. Some of those can be kind of stuck in there. Little WD-40 or similar can really help. Also, when you're doing some of these hoses, double check them. Like this one was rotted away, I've replaced it. Another thing that can help with that, but use at your own risk, is some kind of silicone grease. That silicone grease is usually pretty safe for NBR or EPDM type rubbers that these hoses are made out of. If you're really worried, just spit on it. But anyway, it can really help when inserting a hose to help it go on more easily and prevent corrosion of the metals between the hose and the metal, you know, when water gets in there. Okay, hopefully you can hear me. I finally got it running, but not without some trials. A key thing that stopped me from getting it going right away is I had top dead center right, but the little thing inside this distributor cap goes counterclockwise, and I didn't notice that. So that's a big deal because of the firing order. On this engine, it's 1342. So it hits this guy first, then it hits this guy. But I had it going, I thought it was swinging this way, so I had this thing hooked up over here. So pay attention to your firing order. Also, if you have an old belt, might be a good time to change it. Don't forget to tighten everything. I did end up taking these apart because I couldn't start it, and I thought it wasn't getting enough fuel. But these things don't really output a very significant pressure. You won't even know that it's outputting pressure. The engine literally has to suck the propane out of this thing, apparently. Nonetheless, I did take these apart, oil some of the stuff with silicone oil and grease, silicone grease where it needed it. But as you can see, it runs good, sounds good. I did the trick where I loosened that, I moved this around until I had the idle about where I wanted it, but I erred on the side of having it more advanced than retarded, because I read that there's increased danger if it's too retarded in the firing. One thing you want to pay attention to on these forklifts, at least with this one, this shifter has a safety feature in it. It won't start unless it's in neutral. But in my case, you have to actually hold this forward just a little bit. So it's in neutral, but at the top end of it, to do some kind of electrical switch in there. It was bugging me. I was troubleshooting it electrically, and then I decided to check if the ignition switch would form continuity to the starter solenoid, the big starter solenoid that's attached to the starter, and I kept on not getting continuity. There's a middle terminal on the ignition switch, and then that's what goes hot to your starter solenoid. Long story short, I got continuity when I pushed this forward at the top end of neutral. So right now I have this blocked off because it's running and I'm not in it. It makes me nervous. I've never had a forklift before. If you do run this, I think you ought to run it a while and then totally rinse out your radiator fluid if it hasn't been running a long time and if you just did a job. And then also your oil. Before you start it, drain a little bit of oil in case you think you have any water in there, like from a leaky head gasket. I drained mine, and I had probably about half a pint of water in there. So I'm glad I did. I'm going to let this run a little. I'll do the radiator, and then at some point I'll probably do the oil. Although they just did a fresh oil change. The oil looks really good. There's probably not really any water left in there, so to speak of, but just better to be safe than sorry, you know. So I think that pretty much concludes this project. So this is my place, working on this guy. The lift is great, works good. I'm just gonna lift it up for you guys so you can see it go up. This one I think goes up about 15 feet, something like that. I'm giving it a little bit of gas as I'm getting it up there. So anyway, it goes way up there. It's pretty cool. I don't 100% need a forklift right now, so we'll see. I mean, I do import stuff, but I haven't been importing in bulk lately. So I might just keep this long enough to work on a Bobcat. You can see back there. If I need to pull the engine out of there, this would be a big help, actually. This one here has like this other movement on it. Oops. Like tilt or whatever you call it. It doesn't have side shift. I could probably adjust the timing a little bit, but I didn't want it running too fast, which it was running at a pretty good clip. There's probably a way to adjust the idle, which might be the better way to do it. But anyway, there you go. Good luck on your projects.